Welcome everyone. This is Innovation in the Data Warehouse. I'm Kit Menke. I'm a software architect at Enterprise Rent-A-Car. And this is my co-presenter Scott Shaw, who's
Hello.
a senior solutions engineer at Hortonworks. And before we begin, important announcement, we will have no lasers or loud music. So just sit back, relax. We'll go on this journey together.
Except when we exit the stage, that's when it's all going to start.
Oh, yeah, right. So today we're going to talk about Enterprise's journey to build a next generation data warehouse in Microsoft Azure's cloud, and specifically our move to a Lambda architecture. I'll toss it over to Scott to talk a little bit about forming a center of excellence and how that can help you with implementation. And then I'll discuss some of the pain points that we've experienced. So as we go through this, think about your own journey, and hopefully you can learn from some of our stumbles and some of our experiences. And despite what all the vendors tell you out there, it's not all unicorns and rainbows, so you'll stub your toe a few times. But we'll get there, and you can accomplish some pretty cool stuff. So first, some background on EHI. As you've heard in all the other keynotes, and they say enterprise Hadoop, enterprise encryption, enterprise. This is Enterprise Rent-A-Car. We actually own 3 brands: Alamo, National, and Enterprise. So we are a rental car company at our core. We're also a global company. We're in over 90 countries, over 9,600 locations. And we're also a data company, and we get millions of transactions a year into our warehouse, many different sources. And we've been through kind of a couple of Hadoop implementations. This is really my third one focused on data warehouse, and so that's what we're going to talk about today, is specifically building a new data warehouse. And this is full transparency, we're still kind of in our early stages with this third one, so we have a lot to go, but hopefully we can share some stuff which will be useful. So if I were to just kind of whiteboard out a very simple diagram of what our warehouse looks like today, we have over 50 different internal, external sources which all flow into a data warehouse appliance, which is sitting in our data center. A lot of ETL is performed inside the warehouse, which ultimately makes up over 100 different databases and lots of tables. And then all of our reporting and even some app and some feed stuff, a lot of our analytics, all is also based out of the data warehouse today. So all of our reporting makes up almost 5 million report executions a month and over 1 billion queries. So there's a lot going on there right now. It's also the center of our universe. So we've found some problems, some use cases that don't necessarily fit in the warehouse, specifically like some streaming stuff, data which is changing frequently, structures that are, unstructured data that is hard to fit, and we kind of cram it into the warehouse today where it doesn't really belong. We also have a lot of different competing workloads. So all of our ETL and reporting is out of the same system, which means if our ETL runs long in the morning, it could impact all of the reporting on the system, which we absolutely don't want. So this is a very nice graph of our data warehouse growth over the years. The steps up are the maximum capacity of our warehouse and basically represent a upgrade. So each of those big steps up represents a large increase in cost, as well as many months of planning and hard work that goes into it. The blue line is our disk utilization in the warehouse. So you can kind of see it's trying to trend almost exponentially upward, and we keep kind of bumping into that ceiling. And we've had to do a lot of tuning, a lot of compression, and really straight up just purging data out of the warehouse in order to keep things running smoothly. So it's a big, scalability is a big problem for us right now. So a next generation architecture, what are our main considerations? Well, first and foremost, we want to design for streaming. Everything primarily today is batch. About as real time as we can get is maybe 15 minutes to an hour, which isn't good enough. We want to be able to design for scalability and isolation, and what I mean by this is scale gradually and also scale different components independently of one another. So basically separating ETL out from reporting. If we need more resources for ETL, we should be able to scale that up separately from reporting without impacting reporting. We want to ingest different types of data easily, so structured and unstructured. We don't want to force it into a particular system, so we want to use the right tool for the right job. And in order to get there, we're going to walk through a few of the decision points that we had to make in order to get to our next-gen architecture in the cloud. So first is use cases and data gravity, your workload, and then cloud versus on-prem. So first, use cases and data gravity, the most important. We're focused on data warehouse use cases today. Yours might vary, so take that into account when you're thinking about what you're trying to implement. But a lot of our sources are in the data center today, but we anticipate that they will probably move to the cloud in the future. So if you're not familiar with data gravity, it's just the concept that data has weight, and it's harder to move. The more of data there is, the harder it is to move to something else. So consider where your sources are and how much work it's going to take to get the data from that source into your destination. So if our source is data center and we're trying to move into the cloud, for example. But also consider your consumers. So we have many thousands of locations. Our consumers are primarily in a branch somewhere running an operational report, and they need that. We want that to be as fast as possible for them. We want them to be doing their job, not having to wait for a report. We need them to be focused on renting cars, not waiting for a report to come back. So in addition, we also have a lot of analytic type stuff that we need to do as part of our general warehouse stuff, which works fine in the cloud. It doesn't have to be on-prem in order to do something like that. So last, don't forget about network bandwidth constraints, especially when you're trying to move data around between on-prem and cloud. That how big that pipe is very important sometimes, so don't just keep that in mind. Second decision point is workload. So this is something that I personally have spent a lot of time dealing with, and ultimately it comes down to the difference between batch and streaming. So with batch, you're kind of used to these normal peaks and valleys where you have very high periods of utilization, and then it'll just drop off when you don't have any batch jobs running. Whereas with streaming, you have a need to have your app running 24/7. You need dedicated infrastructure in order to support that streaming app. So it's kind of a change for us. We're used to having dedicated hardware available, but we use it all for batch. So in the new world, in the cloud, we might be able to take advantage of something like the ephemeral clusters. We have a big batch job, spin it up, run the batch job, and shut it down. We're not there yet, but that's what we're aiming for. In addition, you can do kind of some workload isolation within your cluster. I would highly recommend kind of segregating your nodes to do specific jobs. So, run your Hive jobs on certain nodes and run your streaming jobs like Spark or Storm on separate nodes, because there's a lot of work you need to do in order to separate those out. So, unless you want to be like an Embari tweaking RAM and core configs and trying to make sure you have enough headroom for Storm, just save yourself a lot of tears and isolate things with like a yarn node label or something. So you don't want your Storm topology to get hosed when someone like kicks off a big Hive query. That'd probably be bad. Third is just the decision point is cloud versus on-prem. So we ultimately decided to go to cloud for a couple of reasons. The first and foremost is scalability. This is one of our biggest challenges that we have today with the current warehouse is it's very hard, very costly to scale. In the cloud, it's much easier to scale up and out. So that's one of our biggest considerations. The second, though, which I think is equally important, is just what cloud offerings are available. You might be able to leverage a PaaS service out there that does exactly what you want, and then you don't have to maintain the infrastructure. So that's a big win for us, because getting any sort of new infrastructure into our data center is a huge process that takes many requests, and the turnaround time is very long just trying to get a new server installed. So with the cloud, we have a much quicker time to market. In addition, so it goes back to scalability, but being able to scale those components individually, so having ETL separate from porting. And if we're not using a server, we can just give it back to Microsoft, and I don't know if that's ever happened inside our data center. I don't think anyone gives servers back, but no questions asked in Azure, no problem, and then you don't have to deal with it anymore. So I would say my advice, like when you're trying to choose a cloud, Azure might not be right for you, or maybe it works great. It's just how well it integrates with the other tools that you're using. We have Microsoft, a lot of like Office 365, and use Microsoft a lot for the reporting stuff, so it integrates really well for us. But if you don't really need that, then just factor that into your equation when you're choosing a cloud provider. Some other cloud considerations, and I added this slide kind of last minute, but you take a lot of things for granted when you're running on-prem in your data center. With cloud, you just have to factor those different design considerations in. As long as you think about it up front, then you're okay. But my primary example of this is the separation of storage and compute, which oftentimes a lot of these cloud PaaS services like HD Insight take advantage of, where you don't really have data local to the machine. So you lose that data locality, but you gain a lot in scalability. So all your data in HD Insight is actually in something like Blob Storage or Azure Data Lake. And the first time I heard that, it kind of blew my mind, because Hadoop is designed with physical machines, or it was originally designed with physical machines in mind, where the data is running on a disk on that machine, and now all of a sudden you kind of lose that data locality. So as long as you kind of factor that in up front, then you're okay, but otherwise you could get bit later when you're expecting the data to actually reside on your VMs that are running out there. Hopefully that'll go away as we get faster network, but right now you still need to factor that in. Disaster recovery is another big one. Oftentimes with cloud, you have a lot you still need to do, but a lot in cloud is baked in. So backups are baked in, or they give you 3 nines of availability, or you just pay a little bit extra in your blob storage to have it replicated across regions, or so you don't have to really do anything extra. Where on-prem, you have to copy it to a whole different data center or something like that. So hopefully disaster recovery is a little bit easier. And then finally, security, which I've been to a few of the security talks around here, and it's still a very big concern for us. We're planning on having Azure be an extension of our data center, so the same security that applies in our data center should apply in the cloud. We found you just have to spend some more time getting it right. You're not in those. You're not in like the safe space of your data center anymore. But as long as you think about networking and really lock things down, then you should be fine in Azure too. The other thing is, a lot of people seem surprised when the default Hadoop install is just simple auth, which means I just tell you who you are, or I tell you who I am, and you just believe me. If you want true security, then you got to do something like Kerberos, which then brings up other interesting things like, okay, well, you probably want people to log into the cluster with like your normal Windows username and password, right? But you're in the cloud now, so you don't have those connections to your domain controllers in your data center anymore. So, okay, well, we can move the domain controller into Azure, but that might have a repercussion for your whole organization, not just like your particular use case that you're trying to track down. So it's like unravels very quickly, something you need to really, really think about from the beginning. So now we've walked through a couple of the decision points. This is just kind of my sweet drawing of Lambda. But I think everybody probably gets it. You just have the batch layer and the speed layer. Batch you process with like Hive or Spark, and speed you're doing like Spark streaming or Storm. I've altered it a little bit though, and the second part is just your serving layer. So with the speed layer, you're going to some more real-time view. In the batch layer, you're going to some more batch type view. And the real gist of Lambda, I guess, is you're trying to combine the best of both batch and streaming. And the downside is that you might have to use two separate frameworks if you're doing the same logic in both the streaming layer and the batch layer. We're hoping to avoid this by using Spark and then publish to just the appropriate serving layer. So avoid having two separate code bases. So I talked about kind of the concept of a serving layer, and I think it's more easy to visualize in a triangle where at the bottom you have most of your data sitting, and you can store it in a more cost-effective manner, but as you go up the triangle, you'll have less data, but you'll probably be paying more for an increased performance. And the way it looks like with kind of a service is at the bottom you'd have something like blob storage, right, where this is like your data lake layer. You store everything in kind of its most raw format. And then as you move up the triangle, you get into like HDFS or Hive or something where you're doing a lot of your ETL processing. It might still dump it back into blob when you're done, but might use HDFS there for kind of an intermediate. And then near the tippy top, you get into like the NoSQL or relational or cube type stores where it's optimized for a specific use case, which we still will have in kind of our new world. So back to kind of a simple whiteboard drawing of kind of our future architecture. It's still Lambda, except now like the major difference between our previous architecture is we have that streaming layer built right in, going through Kafka. So this could be our stuff like our CDC data streaming in real time that then we would process with something like Spark Streaming. For our normal batch processing, we will land it in blob storage, process it with Spark. It could be multiple Spark clusters, it could be one, but like I said, with workload isolation, you might want to split that stuff out and then publish to the right serving layer. So we think that we'll still have a need for a lot of these dimensional and relational type stores. as well as like NoSQL for like HBase. That'll help a lot with our real-time streaming type stuff. So this is kind of our data lake. So I found this awesome comic by Daniel Story, which I just wanted to show because it's super true. We have a lot of dragons in our data center today, and we're trying to like embark on this journey to create a new, something completely new and different in the cloud. So, you know, we walked through all the decision points. We got our great architecture, so you know it should be easy to implement it, right? But it's not. Surprise. And enterprise has been around for over 50 years, and we have so many dragons kind of laying in wait there that it's going to take a lot of work. So who is really going to help you get there with implementing an architecture? You really need someone who's going to be the tip of the spear. So in that case, one strategy is to create like an innovation team or a center of excellence, with a bunch of people who can learn quickly, adapt. They're kind of out of the day-to-day support of the legacy system. So I'm going to hand it over to Scott here, and he's going to talk about Center of Excellence.
All right. Thanks, Kit. Yeah, I'll go over this pretty quickly. So what we see, believe it or not, what we see in the market is usually a pretty predictable maturity model for companies. Now, I think Kit's being somewhat humble because they've been doing this for about 3.5 years. And normally companies start here at the potential. So we always talk about, you know, innovate or renovate. You know, the renovation is stuff where you can get a pretty immediate ROI by reducing costs somewhere else, like EDW optimization or something of that nature. Innovate are those really value-driven projects that people work on. And they tend to be a little farther on the scale of maturity. Enterprise actually did it differently. You know, they did it completely backwards. They actually started with an incredibly innovative use case, and now they're going back and looking at some of the more renovative stuff. So every customer is different, but you know, there's been a lot of talk in this conference about journeys, and in fact, they do go, you know, as a company, you do go through a predictable journey. And as a company, if you're saying, well, you know, it's taking a long time, or, you know, we've been doing this for 6 months and, you know, we're still building out a use case, that's pretty natural. And what tends to happen, though, is that as you get up here, it gets exponentially. You know, you start really building out use cases and ideas. And the way we approach it and with customers is we don't see ourselves as, you know, a company that wants to be staff aug or anything of that nature, right? We're an agile company. We work agilely with our customers, and so our expectations is we would come in if you're an early adopter or early in your phase. You know, we come in, we help you get started, knowledge transfer. I'm constantly working with Kit about advice. You know, he comes to me with questions, and I ask him questions too, and so it's kind of this synergy. With the idea that eventually you're driving on your own, right? And as an organization, you have lines of business working with IT. You have a good staff, and you're working on your own, and you're using us as just kind of as a place to knock ideas off or escalate issues and things like that. And we try to help prevent any bottlenecks. You know, so we're taking, you know, it really is a 3 months to 18 months journey, depending on your organization and how, and the skill sets within your organization. Now, as far as skill sets, this is usually what I normally see within organizations. Probably the main thing is usually your Linux Windows administrator will be your cluster ops and admin. Before Kit started programming Java and building out storm topologies, he was a SharePoint.net programmer. So it is possible. So to have, you know, to make this trade-off with your, you know, and build your skills internally or hire externally. And then of course we help you do this through training. And the way we look at it is there's always some core learning that I think all should go across your organization. That includes the business units. You know, I feel like the business units will function a lot better if they have core understanding of a distributed platform. You know, they really understand the benefits and the value and what's, you know, and how to leverage it the best way possible. And that's why we also always recommend training prior to any POCs or something, because if you do training after the POCs, you always think, man, if I'd known that before the POC, I would have done things differently, right? And honestly, once you get the training, almost every time, if you look at like Progressive Insurance and the snapshot and things like that, that wasn't their first use case. Their first use case was like weblog ingestion, right? So your first use case may be important, but it's probably not going to be the most valuable one. You know, as you learn, as you progress, as you mature in analytics and BI and the technology, I think you're going to get more and more advanced use cases. And also as you introduce the lines of businesses. And then, of course, you can start to specialize as you go up, you know, just like any other certification paths, things like that. And so we look at really there's, you know, building out a center of excellence, and we could have a whole presentation just on center of excellence, but, you know, there are the 3 Ps, right? People, process, and platform. It's obviously people are probably the most important part of this equation, and their understanding of the technology, their willingness to be flexible, communicate with lines of businesses, and work with executives to get, you know, executive approvals. And then there's obviously the process, the changing of the process. This is a fairly disruptive technology and platform, so there is going to be some process change. And finally, just the platform, the technical side of it. You know, what tools do you use for what purpose and understanding all that. And that's, you know, that's how, you know, we help organizations. And it really does take patience. It takes time to build out and become mature, be mature in this field and get to a place where, you know, like enterprise, where they have both the innovative use cases as well as the renovative use cases in their organization. So.
Thanks, Scott.
Thanks.
So now we're getting to some of the good stuff, which is all the stuff that we ran into. Hopefully we can save you guys some pain and suffering. But the first one is hiring, and I think everybody has this problem. So it's really, these jobs are in high demand. It's a very complicated ecosystem. I went out and looked at the Apache Software Foundation site, and there's like 48 different big data projects, and they didn't even include HBase in that, so I don't know, there's like, got to be over 50 or something now. And even if you find someone who has some experience, it's just, you're not going to find everyone who has experience with every piece that you're using, so just low overall experience. As a workaround, kind of what we did, especially for our innovation team, is we looked for those people who can learn quickly and have transferable skills. So, for example, any sort of Java experience would be valuable for kind of a developer. Any sort of Linux admin experience would be useful for a Hadoop administrator. So find those people who are excited about it and willing to learn, and that was the main thing for us. Like Scott said, I came from like a .NET background, so you know, if I can learn it, then. The second main thing is really a culture problem, and probably at any big company you'd have this issue, but change is hard. You know, it's tough to move to these like brand new technologies, and you kind of get in your comfort zone of working with, you know, what you know. So I sort of feel like you have to break out of that mold a little bit and really expect to, especially if you're in IT, to reinvent yourself every few years even. And as a company, we should look to hire software engineers, not just a Java developer or Python developer. You know, we want DBAs, not like Oracle or SQL Server or whatever DBA is. Like all the concepts that you learn as part of that still can apply to all these new technologies. So just don't limit yourself to one particular thing.
Yeah, one quick point about that is I had a coworker that talked about that companies don't want to hire database architects anymore. They want to hire data architects. You know, they don't want database application developers, they want data application developers. So it's a distinct difference. You know, it's the difference between, are you data driven? Are you looking at data as currency and a platform for your business, or are you just looking at data as an application? I thought that was a really interesting viewpoint.
Some other lessons learned, this is kind of my random slide, but workload isolation, like we talked about earlier, it's possible, but it takes a lot of work if you want to use the same cluster. So this is getting better with Yarn, all the Yarn improvements, but still it's a pain. You don't want your batch jobs to interrupt your streaming jobs. If you have a lot of monitoring in place, then you could probably do it correctly, but it's fairly tricky. So debugging and development is one that we've really struggled with. So there's a ton of software. All of it needs to work together in a particular way. And you know, when your Hive server 2 for some reason forgets its Kerberos ticket, you know, where do you even start? Like what machines do you go to and look? Where are the logs on that server? So it's just distributed systems work differently, and your logs are spread out across all these different machines. So how do you tackle that problem? And as well as development environments, because all that software that you have running out in your cluster, your developers want to use as part of their development process. So you know, what do you do for that? For us, we tackled that with kind of a single node VM that we could run on the developer's PC so that they have the software there. But now we're moving to cloud, so like you have all these cloud services that you want to use as well. So it's just kind of one thing after another. Technologies we like, Hive, because we're a data warehouse. We love SQL, of course. HBase, we've had some pretty good experience with it. It's fairly bulletproof. Spark, we're getting started with, but like it already. I'm trying to wrap my brain around Scala. Some things we didn't quite like so much were Uzi and Scoop, because it just seemed like kind of a lot of setup and some things that we need to address in the future, just how to deal with the number of projects and the licenses for all those projects. Luckily, most of them are Apache 2, but if they're not, you know, Enterprise has a very rigid FOSS process that you have to go through and extremely painful. Schema management, before we just had to deal with a relational database. Now we have to deal with like Hive schemas and schemas on Kafka and all variety of different structured and unstructured data in Hadoop, and then probably we'll still have these relational databases in the cloud as well. So how do you handle all these different disparate schemas that have to like kind of work together or not? And then evolution, because each of those different systems is going to evolve schemas differently. Avro, you might be able to do some sort of schema evolution, but so it's tricky. And just dealing with the different data types, it's almost like having it in a database was kind of nice, because then you have a real rigid schema for everything, and now we might have data coming in which doesn't have a schema with it. So how do we handle that, and how do we certify data and publish it to our consumers? And finally, kind of some agile stuff. We switched to Scrum for our project management stuff. And I threw this in here because it was kind of a lot with it's kind of the same thing with our big data stuff. Give yourself time to learn it. We kind of jumped in head first and tried to like plan everything out and get all our dependencies mapped out and all our deliverables. And it was just too much. We need to like take a step back and give ourselves time to kind of adjust to the process. And so I would say make your deliverables small, even though you might have an aggressive timeline. I don't know if anybody else has those. And there's a lot to learn, so be prepared to fail quickly and change course. So in conclusion, we kind of talked about enterprise and our journey to Lambda in the cloud and some of our decision points that we had to make along the way. We talked about how you could form a center of excellence to help you get there. and some of our experiences along the way. So enjoy the journey as this happy elephant is on the road. And I guess...
So I think we got a few more minutes for questions.
Yep.
Any questions for us?
In your center of excellence, whenever you form stuff like that, no matter what it is, were you seen as like, oh, first of all, you're probably seen as a cool place. First of all, you're probably seen as a cool place to go, but then are you also seen as a bottleneck? Did you ever run into any of that? Like,
So-
I got to go there to get anything done now, or any cool
Oh,
thing
to the
done.
Center of Excellence?
Yeah, the center of excellence.
Well, the Center of Excellence isn't supposed to be like a different, cubicle where everybody sits that knows, the Hadoop stuff. I think the concept of the Center of Excellence is kind of retraining a lot of people within your organization. So it's almost like restructuring your org structure under new processes. So ideally, it should be easier to go and get the stuff you need. So I remember, I think it was ExxonMobil mentioned earlier that they were it was one of the companies. I think it was an insurance company. They had a high growth, like lots of nodes they were adding on, and they were able to do it because they had a dedicated infrastructure team just for provisioning Hadoop nodes. And I think that's key because then you don't have to go through the normal rigorous structure that a lot of more traditional organizations have. And I think enterprise has that issue a lot too. You know.
Well, I'm on the Center of Excellence, so of course we're not a bottleneck, but the goal is just to really learn stuff quickly and then accumulate all that knowledge and then bring it back to the rest of the department to pull them forward. So our idea is we'll start bringing more and more people kind of into the fold, into the new.
So are you actually just bringing people in and they're moving out into other areas? How does that work practically? Or maybe you're at the beginning, I don't know. Push anybody
So
back
are we
out?
bringing people in and pushing them out to their areas? I think they just sometimes just go through a title change,
Yeah.
right?
Yeah, I mean, it's really the training, try to transfer some of the knowledge that we've gained to them and, bring them in to work on the new system.
Do you have a question? Yeah.
I think I read in the description that you guys are on Azure, right?
Yep.
Do you guys find yourself using some of the Microsoft SQL to complement the Hadoop stack? Obviously, some of the Hive stuff is not great for fast response. So what else do you use a part of the Azure stack that complements just a pure HDP?
Yeah, definitely. So that was kind of my concept of serving layers. I ran out of room to draw on the slide though, but SQL Server will still have a use for relational structures that will publish into SQL Server, analysis services for some type of cube. We want to get to something like Power BI and SSRS for like the reporting and visualization. So yeah, definitely. We're going to try to take advantage of as much of that, but rather than having it crammed all into one thing, we're going to pick the right tool for the right job. So if a cube makes sense, we'll put in a cube. If a reporting structure in SQL makes sense, that's what we'll do.
And I'd love to talk with you online about Hive not being fast. So. Yeah, I know.
Yep.
Right, we can still talk about that.
Any other-
I think we're done. So, Kid and I will be up here for further questions. But yeah, they're going to start kicking us out of here. So,
Give feedback in the app.
yeah, feedback in the app.
Thanks a lot for coming.
Evaluation. Really appreciate it, guys. Enjoy the rest of the conference.